Hi guys, this is your last note section before your quiz, and it's not too long, so I think you'll be okay with it. It is on composition of functions, and all of us should have done some composition last year in Algebra 2, so this should be mostly review for you. All right, we're going to find the composition of two functions, and the new thing is decomposing, but I don't think you'll think that's too hard. Okay, so what is a composite function? A composite function is when one function follows the other. Basically, composition of functions, what I like to think of them is they're super machines. And what happens is one function follows the other. And what this looks like with the machines is that you do a function f, and then right out of f, it falls right into another function, g, and then if you plug 2 in, something happens, and maybe a 5 shoots out, and then something happens, and then a 12 shoots out. This is a composition, and then what we're going to do when we find the composition is we are going to make a super machine that instead of having these two rules just has one rule that combines them both, that when you plug in 2, it just shoots out a 12. Okay, so that's the idea here. Now, the notation is this. Whatever happens first is what is listed second. So this particular machine would be G, O, F of X. And what we say is the little O, we say G follows F. And because G follows F, that means F happens first. Most kids don't like this notation. They like this notation better. And we say that's G of F of X. And it's easy to remember what happens first because of order of operations. It will be the innermost parentheses. So that's why F of X is happening first. So once we find the super rule, that will be G of F of X. Okay, so here's an example. F of X is 2x minus 5, and G of X is this guy. So we're going to find F follows G, so G is going to happen first, and then in a minute we're going to find G follows F, where F happens first. So the first thing I do when I have this notation is I change it to the notation I like better, which is F of G of X. We start with our innermost parentheses, which is G of X. And I'm like, what's G of X? Well, good news, right up here, they told me what G of X is. So I'm going to take out this G of X, and I'm going to put what it told me it was instead. So that's F of X squared minus 3x plus 8. Now that looks weird, yes, but this is a set of directions. It's telling you to go to function f. Here's function f. Take out the x, you have to take it out, and put in its place, in parentheses, all of this. So my new guy will be 2 parentheses, x squared minus 3x plus 8 minus 5. It will kind of look like what you originally started with from a distance. If you put a big X over the parenthesis to x minus 5, it looks kind of the same. Then you'll have to clean up and distribute. So that's 2x squared minus 6x plus 16 minus 5. And I get 2x squared minus 6x plus 11. So that is the super rule. So what this is telling me is if I had a function machine where g was first, which is x squared minus 3x plus 8, and then those answers dumped into 2x minus 5, I'll get the same thing as if I plug it in here. So let's practice. Let's say I plugged in a 0 into this machine because it's easy to plug in a 0. If I plug in a 0, 0 squared minus 0 plus 8, an 8 comes out. If an 8 goes into this machine, 2 times 8 is 16. 16 minus 5 is 11. Well, I said for the super rule of this machine could just be 2x squared minus 6x plus 11. If I plug 0 into this rule, will it also shoot out an 11? The answer is yes. So this is the rule that combines those two functions together. Let's try g follows f, or g of f of x. Start in the innermost, and this one's going to be significantly harder, so please be careful here. This will be g of 2x minus 5, and hopefully you can see why it will be harder, because it's the same issue that I told you a lot of Algebra 3 kids make. When you plug in this 2x minus 5 into function g, you have to take out that x and put in the 2x minus 5 in parentheses, and look, it's squared. So we will have to double distribute there. Once again, if you put an x over top of the parentheses, it will look like what you're having here, x squared minus 3x plus 8. This is the part that's tricky. That's a 2x minus 5 times a 2x minus 5. We will have to double distribute 4x squared. I don't know why I wrote 4 that time. Minus 10x minus 10x. It's minus 20x plus 25 when I take a negative 5 times a negative 5. Also, I have to distribute this negative 3, so it's negative 6x plus 15. A lot of us are making sign mistakes on the second distributing there, plus 8. Clean it up. 4x squared minus 20x minus 6x. It's minus 26x. Then I have 25 and 15. It's 40 plus 8, getting plus 48. So the machine shortcut where if f happens first, which is the 2x minus 5, and then those answers plugged into x squared minus 3x plus 8, that will give me this guy as a shortcut. If you want to practice, we could plug in the 0 again. If you plug in a 0, this guy will shoot out a negative 5. But if I plug in a negative 5 into that equation, I would get 25 plus 15 plus 8, and it would shoot out 48. If I plug 0 into this shortcut rule, it also shoots out 48. And you can plug in any number. I just like to pick 0 because it's a little easier. Okay, so that's compositions of functions. Now, domain. So what happens with the domain? First of all, if there's no risks, it's still negative infinity to positive infinity. But when you are dealing with domain and compositions, things do get a little bit tricky. I like to draw a picture, or you can actually just solve the math and then look at the new equation if you want. Okay, so those are your options. So let's try this. F follows G. That means G happens first, which in this example is x minus 3. And then it goes into the square root of x. X minus 3 is not going to be the problem here. The problem is the square root of x. So when you think about plugging numbers into the machine, you have to say, will anything break this machine? And the answer is no. I can plug whatever I want in there. So this is not the problem. So this guy is shooting things out. But the problem is right here. I cannot plug in anything less than 0. X has to be greater than equal to 0. But I don't plug into this machine. I plug into this machine. This comes from that. So what this tells me is x minus 3 has to be greater than equal to 0. If you solve it, that means x has to be greater than equal to 3, and that is the domain of this composition. If you don't understand the pictures, your other option would actually be to do the math. F of g of x. G of x is x minus 3, so it's f of x minus 3. Go to function f, take out the x and put in the x minus 3 in its place. And now you can say, hey, wait, there's a risk. And it's the same thing we just had. X minus 3 has to be greater than equal to 0. So x has to be greater than equal to 3. Now, what if I change the order? What if I do G follows F? What if F happens first? and then that goes into G. Well, can I plug anything I want into this machine? No, this is the one that's a problem. That guy, x has to be greater than or equal to 0. After that, though, nothing can break the second machine, so my domain on this one is a little bit easier. It's just x is greater than or equal to 0. If you're doing it with the math, g of x, f is the innermost. That's g of square root of x. Go to function g, take out the x, and if you notice, there's a cap on the end of my x because the minus 3 is on the outside, so this is the only risk factor, and x has to be greater than or equal to 0. So that's domain. We'll have time to practice that if that's still a little tricky for you. When you decompose functions, it's kind of an idea that we do in calculus. You have to see that there's two functions related. And what we will do usually is just put your finger over where the parentheses is, and you can kind of see what the two functions are. Basically, this says f follows g, or g is inside of f. So if you put an x where the parentheses are, you can kind of see what the original guy was and what you plugged in. So g of x is what we plugged in. That's the 2x minus 3. And once you see the parentheses and you exit out, what's left would be your f of x, and that's where we plugged in the x to the fifth. Because there's an x there now, we plugged this into that. There are a couple of examples that you'll be able to look at on your math lab. And that's it.